Welcome back. So today we're going to be working on chapter 8. So we're going to be starting with 8.1 here, which is similar polygons. You're going to need your doodle notes page that looks like this. We're going to be working on both the front and the back side. We're also going to be doing some highlighting today. So if you have highlighters or colored pencils that you'd like to use to help mark some things, I would suggest grabbing those. All right, so we're going to start out similar polygons. So the first thing I want to call your attention to is the symbol that we see here. So we have this little squiggle mark. So that should look very familiar to you. It looks like the top of our congruency symbol, and that actually means similar. So if we look down in the first paragraph, it says when figures have the same shape but different sizes, they are called similar. The apples to the right are similar. The symbol that we use is that little squiggle shape. So that's the first thing we're going to do there is we're going to highlight that piece. So like I said, similar is when we're talking about two objects being the same shape but different sizes. So they could be bigger or they could be smaller. And we talked about this a little bit in chapter 4 when we were dealing with our transformations. We talked about translations, reflections, and rotations that were congruent shapes. And then we also talked just a little bit at the very beginning about dilations, which is getting bigger or smaller. And so a dilation is a form of similar polygons. We're making it bigger or smaller depending upon what you're doing. A map would be another example of similar shapes. When we take a map, let's say a map of Kansas, it's not going to be the same size as Kansas actually is because that would be too big for us to be able to use. So we make it a lot smaller, but the exact same shape. Okay? All right, so the next piece that we want to talk about is our corresponding parts. So if you remember back to chapter 5 when we were talking about congruent shapes, we also identified corresponding parts. So remember, for them to be corresponding, they have to be in the same position, just on a different shape. Okay, so that's the first thing that we're going to do here with our triangles is we're actually going to be highlighting some corresponding parts. So I'm going to start out by looking at my small triangle, and I'm going to highlight the shortest side, which is my 1.5. And I'm going to do the same thing for my large triangle. So the shortest side on this one is my 4.5. So I'm going to highlight that with the same color. Okay, because those are corresponding parts. The next one that I have, the next smallest on my small is going to be the 3.2. So I'll use a different color here. 3.2. And then I'm going to go to the large triangle, same thing. I've got my 9.6 is the next smallest. And then the last one is going to be my 4.5. That is the longest side, and that's going to match up and be corresponding with the longest side on the other one, which is the 12.75. Okay? So for figures to be similar, they have to meet two requirements. When we talked about congruent shapes, we said that they had to have congruent angles and congruent sides. Now that we're talking about similar figures, then our corresponding angles still have to be congruent. Because if you think about it, a triangle, we said every triangle adds up to 180 degrees. That doesn't change depending upon how big or small it is. So the total is still going to stay the same. So our angle measurements, it only sounds reasonable that they would also stay the same. And if they're going to stay the same, we call that congruent. So the corresponding angles must be congruent. Okay, the next one, we're going to look at corresponding sides. And that was what we were marking here. We were marking some of the corresponding sides. For these two shapes to be similar, those corresponding sides must be proportional. Proportional. Okay, and what that means, if we look right down here, proportional means that we're going to reduce to the same fraction. So if I take this orange over the orange, so that's going to make a fraction, and reduce that down, I should get the exact same fraction when I do that with the pink and with the yellow. And we'll do that here in just a minute. Okay? All right, so the next thing that we're going to do here, since we were talking a little bit about angles, we're going to come up here and look at our angles. So we know that every triangle has to add up to 180 degrees. So we're going to take our small triangle and we're going to add the 92 plus the 39 and subtract from 180 so we can figure out the measure for angle R. Okay, so again, we're going to take the 92 plus the 39 and we're going to subtract that from the 180. So 180 minus those. And that's going to give us 49. So we're going to mark 49 here. We're going to do the same thing down here. We're going to take 92 plus 49, and we're going to subtract that from 180. And we get 39, so we're going to mark this last one as 39 degrees. Okay, so now we're going to highlight those corresponding angles since we have all of them. So the first one I'm going to look at is my 92 and my 92. So we're going to mark those as corresponding. The next one is my 49 and my 49. Those are corresponding. And then the last one that I have is the 39 and the 39. Okay, and we can actually mark those as well here. Okay. All right, so we are going to decide if these triangles are similar or not. So we're going to check first, looking at our angles. So are the corresponding angles congruent? So we said there's a 49 and a 49, a 92 and a 92, a 39 and a 39. So are they congruent? We're going to mark yes. Next one, we're going to be looking at our sides to decide if they are proportional. So like I said, we're going to be making a fraction. So I'm going to start with my pink sides, and I'm going to go small over large. Okay, it doesn't make any difference which way you do it as long as you're consistent. So I'm going to have 1.5 over 4.5. Okay, that's my small over my large. Equals, we're going to go to the orange, 3.2 over 9.6. And then the last one is the yellow, 4.25 over 12.75. Okay, so now it said here for it to be proportional means they need to reduce to the same fraction. So we're going to reduce each of these fractions. 1.5 over 4.5. There are 3 1.5s and 4.5, so that becomes 1 over 3. So let's see if the same thing works for this fraction. If I take 3.2 times 3, would I get 9.6? Yes? So then we're going to mark that as 1/3 also. And then the last one, if I take 4.25 times 3, do I get 12.75? I do, so we're going to mark that also as 1/3. So since all of these reduce to the same fraction, we can say yes, those sides are proportional. Okay, so then the last piece here, since these triangles are similar, we're going to write a similarity statement. Just like when we were doing our congruency statements in chapter 5, order matters. You still have to match up those corresponding parts. So that's why it's really important that we match those up. So I'm going to start with my triangle symbol. And I'm going to look at my small one just because that's the one I chose to start with. And I'm going to name this RMS. RMS. So I went from green to blue to pink. So I'm going to do the same thing over here. Start with my triangle symbol. Green is S, blue is G, pink is T. So SGT. T, because we want them in corresponding order. So R and S are congruent, M and G are congruent, and S and T are congruent. Excuse me, that should be F, not S. I apologize. RMF. Okay. All right, that's all we have for that side. So let's go ahead and turn it over. Now we're going to look at scale factor. So when we're solving problems involving our similar figures, the first thing we have to do is we have to find the scale factor. So that's actually what we were doing right over here. Down at the bottom when we reduced those sides, was we were finding the scale factor. All right, so what we're going to do here is a scale factor is the ratio of two corresponding sides that have numbers, no variables. That's important. Okay, so the triangles to the left, they're telling us that these are similar. So the first thing we're going to do is we're going to write our similarity statement. So we're going to line up those angles and those sides so that they are in corresponding order. Okay, so I'm going to start with the bigger triangle on the left there. And I'm going to start with my triangle symbol. And I'm going to start with S because it has one arc. Then I'm going to go to W, it has two, and N has three. So S, W, N. Okay, it is similar. Let's do the same thing here. We're going to go K, H, B. K to H to B. Remember, we went one arc, two arcs, three arcs. So it makes it really easy to remember and line those up. Okay, the next thing it's asking us to do here is to find the scale factor of the large triangle to the small triangle. So we're going to go large over small. Okay, so in order to do that, we're going to line up those sides. So SW here, and I'm just going to highlight some things so that we have those together. So SW goes with KH. The next one that would partner up is WN. WN is my next two letters, that's HB. And then the last set is SN. And that's going to line up with KB. Okay, so now that I have those identified, I'm going to go ahead and write out my proportion. So I've got 12 over 8. I've got 18 over X and 15 over Y. So if we look at these, they told us up here no variables. So we're actually going to look at this one, my 12 over 8, and we're going to simplify that. Remember it said we had to simplify it. So what goes into both 12 and 8? 4 goes in there. So we're going to divide by 4, both top and bottom, and we're left with 3 over 2. Okay, so our scale factor is 3 over 2. All right, so now if we look at the next piece, we're going to use that scale factor to help us solve for X and for Y. So we're going to set up two different proportions in order to do that. So the first one, we're going to take our scale factor, 3 over 2, equals the one with the X, which is 18 over X. The other proportion, we're still going to use our scale factor of 3 over 2, equals the other ratio, which was 15 over Y. From here, we're going to solve using cross multiplication. So we're going to multiply diagonally. So that means we're going to take 2 times 18 equals my 3 times X. So 2 times 18, we get 36 equals 3X. Dividing by 3 on both sides, we get X equals 12. Okay, the next one, again, we're going to cross multiply. So 3 times Y equals 2 times 15. So we have 3y equals 30. And then we're going to divide by 3 on both sides. And we get y equals 10. So we found the x value and the y value. And that's all they asked us to do here. Using the scale factor, we're going to solve for x and y in these triangles. Okay? So the next piece is the solve. So I'm actually going to have you go ahead and solve these on your own, and then you'll bring this in for me to check in class. Couple of things to remember. We have to line up our corresponding parts first. So this 93-degree angle goes with this 93-degree angle. So then the 2x plus 13, that's going to correspond with this 67-degree angle. So those are corresponding parts. The other piece that we have, and I'll just highlight these for you. So we have side lengths. Remember, side lengths are proportional. So we have the 2y plus 2 is going to match up with the y plus 3. And then the last one is this side over here is 2, and this one is 3. Okay? So remember what we did before. How did we set them up to be able to solve for x or y when we had a scale factor? So you first have to find that scale factor, and then you can plug that in to help you solve for your variables. The last piece that you'll do on this page is then the challenge. So which of the triangles is similar to the patterned one? So make sure that you're matching up those sides and checking the scale factor to make sure that they are all proportional. All of those ratios have to reduce down to the same fraction. So I'm leaving these two pieces for you to do on your own, and then I will be checking for those when I check notes. All right, that's all I have for you today. Have a great day. I'll see you in class.